Welcome to SQL tutorials. So today we'll discuss about the concept database normalization. Database normalization theory already we have discussed and it is already available in the playlist. You can search for it. And so the normalization, how to implement the normalization at SQL level, we'll discuss. So now let us go with the example. The normalization is a technique or a process to eliminate the redundancy in the database array table, right? So now this is an example. So stepwise I have formulated and prepared. So by taking some example, so by going through this example, once I'll explain this example theoretically, and then we'll go for implementation part. Okay. So now this is the unnormalized form. So it is normalized at. So the name of the table is orders unnormalized form. The columns are order ID, customer name, customer address, products ID, products name, product process. You can observe here this is the table. So we need to understand that so this table, so as we already know that the phases of the normalization, first normal form, second normal form, third normal form. So in this tutorial we will implement the will verify the table is in normalized form. If not, we can check the first normal form, second normal form, and third normal form. If it is in converting into third normal form, then we'll go for implementing the third normal table, normalized table. Okay, in SQL. So in this table, we can see that order ID is 1, 2, 3. Customer name is Alice, Bob, and Alice. Customer address is Delhi, Mumbai, Delhi. Product ID you can mention. You can observe here. So these are this column is this attribute or column is a multi-valued attribute. And product's name you can here also you can observe that this is a multi-valued attribute. So these three columns are attributes. We can say that these three are multi-valued attribute. So as per the rule of first normal form, so these the table should not contain the multi-valued attributes. So once you identify that the table contains the multi-valued attribute, then we have to convert that table into first normal form first of all. So in this table we can observe that dependencies are, so order ID is 1 and product ID. So 101, 102. Okay. So let us first convert into first normal form, then we'll see the dependencies. So now it is converted into first normal form. The first normal form is said to be in 1NF, it should contain only atomic values. Now we have converted 1 Alice Delhi 101, 102, 103, 102. So now we can observe that the table is in first normal form. So once the table is in first normal form, we can see that the dependencies are order ID, product ID determines the customer name, customer address, product name, product ID. Sometimes they will mention the dependencies, but we need to analysis. We need to do the analysis. So order ID, product ID, these two 1, 101, these two are identifying the customer name, Alice, Delhi, and customer name, customer address, and product name. 1, 2, 3. These three are depending on the order ID, comma product ID. So that is the like composite attribute. So in this attribute, it is identifying the customer name, customer address, and product name. And of course, product ID is determining the product price. Okay. So product ID determines product name, product price. That is another dependency you can see here. And one more is available, order ID. Order ID determines customer name, customer address. Okay. Order ID determines customer name and customer address. These are the dependencies. So once the table is converted, Then these are the dependencies are available. In these dependencies, before going to the verifying the second normal form, so the conditions are applied for the second normal form. The condition is table should not contain partial dependencies. So if you observe here, in these three dependencies, customer address and customer name are depending on the order ID. Order ID is the part of the candidate key. Okay. So it is a partial dependency, and otherwise, and second dependency is product ID. Product name, it is depending on product ID. Product ID is also part of the key. So we have observed that two partial dependencies are there in the table. So this is also we have to eliminate. So once it is eliminated, then it will become these tables will be converted into the second normal form. And here we can observe that after converting it to a second normal form, customers is the table, separate table, customer ID, customer name, customer address, and we are dividing that into product ID. Inside the product ID, we are adding product ID, product name, product price. It is another table, and order table is separately created, order ID, customer ID. And we are going to take another table including this order ID and product ID. So if you convert the table into the second normal form, so we'll get all these four dependencies, four tables. So this is called the decomposition process. So how we have done this theoretical part. So you can also search for the video in the channel. So complete in detail. Okay. Now the table is converted into the second normal form. These are the tables are available. First, customer name is having the columns customer ID, customer name, customer address. Product table is having the product ID, product name, product price. And order ID is having the order ID, customer ID. And order details table, this is another relation to maintain the many-to-many relations and to reduce the redundancy. So we have converted, decomposed like this. So here you can see that each table it is having the connection. Customer table is having the customer ID, and customer table and order table is having the common column customer ID here, and product ID is there in the order detail table. So like that we have decomposed the main table into multiple tables. After converting them, you can observe the dependencies. Customer ID is depending, customer name and customer address is depending on customer ID, no issue. Here the candidate key is customer ID, primary key. Product ID, product name depending on product ID, no issue. Customer ID is depending on order ID, no problem. And here order ID and order table. So it is a separate table. So here nothing to determine. So here we can find that no partial dependencies, nothing but this is the converted second normal form. After converting the second normal form, we have to verify that is there any transitive dependency or not. So for example, this customer ID determines customer name, customer address. Product ID determines order ID, customer ID. So from this set of dependencies, if you identified any transitivity, A determines B, B determines C, then A determines C, then that is called the transitive dependency. Here we don't have any transitive dependency, so that's why further no need to decompose this table. So now the finalized decomposition is this one: customer table, product table, order table, and order details table. So accordingly we have to create the tables. So this is the way of how to create the table. I hope you are already familiar with it. Customer table, primary key, and product table, product ID is a primary key, and order table, order ID is a primary key. In order table we are linking the customer ID, so then it will become the foreign key. So and finally relationship table, order details. In this order details we have order ID and product ID. These two will become the foreign keys. Okay, and finally we are creating the primary key of order ID, product ID to maintain the relationship with all tables. So this is the way of creating the tables. So just go to the SQL. So these all tables myself already created. So I'll verify the tables customers underscore tbk. So this is the table I already created. Then description, describe orders table, and so another table is products orders underscore tbk. This is the table, and one more table is describe products underscore tbk. So these all tables are already created. Describe order details underscore tbk. So if you miss any spelling, order details. The spelling is mistake, I think. Underscore tbk. So all tables are created. Then we'll verify. So the data is also inserted into these tables. So as we shown in the presentation or explanation, so already I inserted the data. Select star from customers underscore tbk. So this is the data I already inserted. Otherwise video length will be more. So orders underscore tbk. Data is already inserted as shown in the example. Orders details and products underscore tbk. Products underscore tbk. And finally order details underscore tbk. So all tables are created. So once it is done, you can analyze here. So this is the implementation of the after converting the unnormalized table into the normalized table. So the normalized table is nothing but normalized table is not having any kind of transitive dependencies, partial dependencies, and all. We have eliminated all. Now the normalization or database is designed in a proper way. Not is doesn't contain any kind of so these kind of problems, anomalies, right? So now after finishing this table creation and insertion of the data, so let us solve one or two, three queries for getting the understand. So we'll understand some queries. So the first query will identify that to find all orders with the customer information. So if you want to find out the customer details, okay, find out the customer, find the orders with the customer information. So just execute this. You can see here, select order ID, order customer name. So it is reference o dot order ID, c dot customer name, c dot customer address from orders tbk. Orders from the order table, we are going to retrieve the order ID and the customer table. So let us print select star from orders underscore tbk. Orders underscore tbk. So here you can see orders underscore tbk table, and then we are going to join in the customers underscore tbk table. Customers underscore tbk table. Customers spelling mistake. So now here we can understand so let us take the query. So from these two tables, orders underscore tbk, we have order ID and customer ID. Similarly, customers underscore tbk, we have customer ID, customer name, customer address. So we wanted to print all the orders with customer details. Order ID is coming from here, first table, and the customer name, customer ID is coming from the customer table. So we are going to join them, and we are writing the condition, matching condition. O dot customer ID is equal to C dot customer ID. Here and there we are going to combining, and we are going to getting this result. So this is the way of writing the queries after converting it to the normalization. Okay, so let us solve one more problem. So find the count of products in each order. So in each order, if you want to find out the products, count of the products. So for this all queries, already we have done many videos on this. So just go through the playlist, SQL playlist. So I have done many practiced queries on this, and also each command is explained how to work with the count function and how to work with the group by function. So and how to link a primary key, foreign key, and all everything is available in the SQL playlist. Just go through them. So now this is another query. So select here order ID, count of the product. The question is find the count of products in each order. In each order we wanted to get the product ID. In order ID 1, count is product count is 2. In order 2, product count is 1. In order 3, product count is 2. So for this also we are performing the join between the orders underscore tbk table and order details underscore tbk table. So if you want, you can verify select star from orders underscore tbk. Similarly, order details underscore tbk. So from these two tables, we are getting this count of the product. For example, order ID is 1. So in order ID, we have two products, 101 and 102. So that's why the count is 2. And similarly, order ID 2, 103. It is only one count is there, so that's why 103 product ID. And order ID 3 is again we have two products, 104 and 102, so that's why here count is 2. So likewise we have to perform the different type of queries from the generated designed table or implemented table. And finally, so we can do many queries, but so it takes time. Anyhow, the aim of this tutorial, today's video is how to get normalize the table by removing the partial dependencies and transitivities. Okay, so this is another query. So if you want to just the question is get all products in a specific order. So for example, order ID is equal to 1. Order ID is equal to 1. Just you need to get all the product details. So here order ID is equal to 1. The product details are pen and book. So pen is 10. So if you want, you can print these two tables. We mentioned here the join operation. We can also use the subqueries also, no problem. Order details table, select. So print the order details table, and another one is products underscore tbk. So we can verify in these two tables product underscore tbk. Okay. Get all products in a specific order equal to 1. So you can see here order equal to 1 is specific order details. 1 is a 101 product ID, The one not one product ID is pen, product price is 10. So that's why we printed pen and product price is 10. And similarly, order ID equal to 1, 2 products are available, that's why it is printing book also. It is a price is 200. So this is the how to write many queries after performing the converting the table into normalized table. So that's all about the tutorial. So if you feel this is helpful for you, please don't forget that like the video and share and comment on the video. So thank you all.